Welcome to this SkillPad video resource where we make learning fun. In this video, we are going to learn about pressure in solids and fluids. Ever wondered why dams are built with a wider base or why heavy trucks have huge tires? Well, it all arises from the way pressure works in solids and fluids. It's a fascinating phenomenon where forces in areas interact, substances expand on heating, and everyday objects rely on these principles to function. Pressure, simply put, is the result of a force applied over an area. Imagine walking on a sandy beach. The weight of your body, which is a force, is spread over the area of your feet touching the sand. If the loose material under your feet cannot support your weight, it is pushed further under or away from your feet until stability is realized. Likewise, if a heavy truck were to drive on soft or loose ground with thin tires, it would get stuck as the tires dig into the soft or loose material. This is a classic example of pressure, where a large force is acting over a small area. Did you know that when substances heat up, they expand and create pressure? Picture a kettle boiling water for your tea. The water molecules receive heat, move faster and take up more space, causing pressure to build up. This pressure ultimately leads to the whistle blowing, alerting you that your water is ready. Now let's dive into the world of fluids. The pressure in a fluid increases with depth due to the weight of the fluid above pushing down. This is why scuba divers experience higher pressure the deeper they dive. It's also how barometers measure atmospheric pressure by observing the height of a column of mercury sustained by atmospheric pressure. Speaking of the atmosphere, it's a layer of gases surrounding our planet, exerting pressure known as atmospheric pressure. This pressure is measured using devices like the barometer, and it changes with altitude. The atmosphere is structured in layers, each with its own significance. For instance, the ozone layer absorbs the majority of the sun's harmful ultraviolet radiation. There are numerous applications of atmospheric pressure in our everyday lives. It's the principle behind the working of a vacuum cleaner, lift pump, the siphon, and even a drinking straw. When you suck on a straw, you reduce the pressure inside it. Atmospheric pressure then pushes the drink up the straw and into your mouth. Next, we explore Archimedes' principle. It states that when a body is immersed in a fluid, it experiences an upward force, or upthrust, equal to the weight of the fluid displaced. This principle is demonstrated with a simple experiment where an object is submerged in water, and the rise in water level indicates the volume of fluid displaced. Then we have the law of flotation. It's the reason why enormous ships stay afloat, and submarines can adjust their depth in water. It states that a floating object displaces its own weight of the fluid in which it floats. The fraction of the object submerged is directly related to its relative density. Finally, let's touch on the Bernoulli effect. It's the principle behind the lift of an airplane wing or aerofoil and the operation of a Bunsen burner. According to Bernoulli's principle, an increase in the speed of a fluid occurs simultaneously with a decrease in pressure or a decrease in the fluid's potential energy. This effect is easily demonstrated by pumping water through a pipe with a constriction. In summary, pressure is a fundamental concept in our world, one of underpinning the functioning of many everyday objects and natural phenomena. It's the result of force applied over an area, and it changes with heat, depth in fluid, and altitude in the atmosphere. From the whistle of a kettle to the lift of an airplane, the principles of pressure are at work, making our lives easier and more interesting. Thank you for using this SkillPad video resource. Hope it made light work of the concept of pressure in solids and fluids. Go ahead and check out more of our videos on the same platform. We hope to see you again soon.